Hello my dear viewers, listeners and students. I hope you are doing great and having good health. Once again welcome to Fahad's tutorial, and this class is a very important class of chemistry, and this is about the arrangements of electrons in the energy levels or orbit. So this is very basic and you have to understand how electrons are arranging into the orbits, and this is important. So, according to the Bohr's law, as you know that in my previous classes I already uploaded the Bohr's law and Rutherford's law, and you know that according to Niels Bohr's statement that electrons is revolving into the circular paths, and these circular paths known as energy levels or electrons or shells, and this is denoted as KLMNOP shell according to the number is, if it is number of 1 then K shell, number is 2 then L shell, so it gradually develops. So right now we need to understand two important things, that is orbit, and then we need to understand one more thing is orbital. So what are these? As we know that from the statement of Bohr's model, we have orbits like K shell, L shell, M shell, N shell, O shell, P shell, like n equals to 1, 2, 3, 4, 5, 6. So you know it well. I mean, when in the atom we draw some circular paths, then we know that this is known as the energy level or the orbit or the shell. So we must know these words, that this is actually orbit or shell or energy level. But what are these orbital? If this orbit is actually the energy level, then this is actually the sub-energy level. So these energy levels known as K, L, M, N, O, P shell, but the orbital will be expressed as small letter S, P, D, F. Now the question is how it comes from and where it comes from and why this is denoted as S, P, D, F. I will explain these things in a different video, that what is actually the orbit and orbital, but most importantly in this video I shall explain how the electrons is arranging around the nucleus. The story of orbits and orbital will be explaining later, but before going to explain these, we need to know that S, P, D and F orbital. I mean, orbital is a place of orbit, the sub-level of orbit where there is a probability of having more electrons. So the orbitals denoted as S, P, D, F, and each and every single orbital has a fixed number of electrons. So this is actually S orbital 2, P orbital 6, D orbital 10 and F orbital 14. So this is the limited number of electrons can be obtained by this orbital. So keeping eyes on these things, we need to understand how electrons organized or arrangements is going on. So we know according to the rules of 2n square. According to the rules of 2n square, what's going on? When n equal to 1, what's going on? It means if n equals to 1, then the rules is 2.1 square, that means 2 into 1 is 2. So when n equals to 1, it's actually K shell, and when is actually the L shell, what's going on? It's 2n square. If this is 2n square, we need to know that this is actually the energy level 2. So if n equals 2, then how many electrons can be in K shell? It will be 2 times 2 square, so which is 4 times 2 is 8. So maximum 8 electrons can be in the second shell or L shell. So if M shell, then we know that in 2n square it will be what? it would be n equal 3, and if n equals 3, then 2 dot 3 square would be 18. So it means that maximum 18 electrons can be present in the third shell. In n shell, what? According to the same thing, then it would be like n equal 4, then it would be 2 dot 4 square is 32. So we can go further like K, L, M, N, O, P, Q shell based on the number of electrons. So we can have this number of electrons arrangement into the shell. So we can say that if this is the nucleus and this is the first shell, so in the first shell we can have 2 electrons. In the second shells we can have 8 electrons. In the third shell we can have 18 electrons. So I'm not putting these electrons here, it will be more. So according to the 2n square theory, we know that how many electrons can be in different shells. But when we do the electron configuration, we need to understand that there are some sub-levels of these orbitals or energy levels. Like what? SPDF, how this will happen? How this will happen, I'm explaining this one right now. So I hope this is very understandable and easy. So I'm removing this one. As you know that in this orbit there are one or more than one orbitals into all different energy levels. Like what? When n equals to 1, when n equals to 1, there is an orbital which is 1s. When n equal 2, that means L shell, it can be 2s and 2p. How it comes, I will explain it later, but you must remember that in the second shell there can be 2 orbital, and then in number 3 we must know there is 3s, 3p and 3d. So similarly, when n equal 4, it can be 4s, 4p, 4d and 4f. So it's increasing gradually and then it will decrease gradually. So n equal 5, here we have 5s, 5p, 5d, 5f. And then when n equal 6, then we can have 6s, 6p and 6d. When n equals 7, we can have 7s, 7p, and then n equal 8. In case of 8, it will be 8s. So we can see that according to the number of shell, it gradually increase and then gradually decrease. So if I remove these, we can have a clear view of the orbitals, and then we will draw some oblique lines that how energy levels is distributing here. That at first we can have 1s orbital, and then we'll have 2s orbital, and then we have 2p, then 3s, and then 3p, 4s, then after 3d, 4p, 5s, then after 4d, 5p, 6s, then after 4f, 5d, 6p and 7s. Lastly 5f, 6d, 7p, 8s. So according to these oblique lines, electrons will be distributed to their designated orbitals, and through this way we have the series of electron configuration like 1s. As it is, we know that s orbital can have 2 electrons. We need to say 1s2, and then 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 5f14, 6d10, 7p6, 8s2. So we got this from these oblique lines, and I hope that you already know this one which is given on your books. Because of this arrangement, we can understand that how many electrons can be with this thing. So we can have like S. So all the S orbital will have maximum 2 electrons. All the p orbital will have maximum 6 electrons. All the d orbitals will have maximum 10 electrons. And in case of F will have 14 electrons. And this is the arrangements of electrons. And now we can say that electron configurations like this. And if you see that the number of electrons will be following through the arrangements of orbitals based on the proton numbers of an elements. Suppose if I go for helium. So if you know that in your periodic table helium is the inert gas located in the first number of 18 group. So the 18 number group is all about inert gas and the first element is helium, and the number of proton or electrons helium is 2. So the only electron configurations of helium would be 1s2. But if we go for sodium 11, so there will be 11 electrons. So we say 1s2, 2s2, 2p6, 3s1. So according to this arrangement, we can see that sodium has 3 shells. In the first shell, according to 2n square law, there will be 2 electrons. In the second shell, 2 and 6, 8. And in the third shell, there is 1. So the sodium 11 arrangement is 2, 8, 1. So it also follows the rules of 2n square like this. But there are some exceptions, like in case of chromium and in case of copper. There are some exceptions because there are some things that you need to remind, that in case of chromium 24, in case of chromium 24, we need to reach 24 according to this arrangement. So this would be like 1s2, 2s2, 2p6, 3s2, 3p6. So according to this law, after 3p6, 4s2 should come, and then after 3d. But for the arrangement, we will write here 3d first and then 4s. Now what will happen? We need to count that there will be 24, so 2 to 4, 6, 10, 12, 18, so 6 more electrons should be placed. So here, according to rules, if I give here, so after 3p, electron will go first 4s. As you know that electron will go to the lower energy levels and then to higher energy levels. This is very important to know that the energy of 4s orbital is less than 3d orbital. How it comes? I will explain it when I will explain the quantum number. And then the summation of principal quantum number and additional quantum number, the 3d orbital energy is higher than 4s orbital. So at least we have to input first 4s2 and then 3d4, but it's not the right configuration. Why? Because we know that 4s would be the first priority, but if there is 5 and 1, it is more stable, and for that stability 4s would be 1 and 3d would be 5. So in case of chromium, we can see that for the first time that here in first shell there will be 2 electrons, in the second shell there will be 8 electrons, In the third shell, there would be 13 electrons, and in the fourth shell, there will be 1 electrons. So the electron configuration of chromium is 2, 8, 13, 1. So there is 1 electrons in the fourth shell and 13 electrons in the third shell. Because in case of 3D, it's always stable. As we know that D2, so in case of D1, S1, P3, D5 and F7 is the half fill of these electrons. So S can be 2 but 1 is stable, P can be 6 but 3 is stable, D can be 10 but 5 is also stable, F can be 14 but 7 is still stable. So here, according to the rules of electron configuration, it can be 3D4, 4s2, but no, it can't be, because when it's 4s1 and 3d5, it gets more stability. So similarly, in case of copper, if you do it on your own, then you'll see that there will be 3d10 and there would be 4s1, but not 4s2, 3d9, no. So you must follow this principle. I just explained very primarily here because there are lots of other things that I need to explain. Some people can ask, some students can ask why the orbital comes like S, P, D, F, because there is some specific name that is sharp, principal, diffuse and fundamental. I shall explain it in other video because I am thinking to upload a video on orbits and orbital to explaining why this orbital is known as the S, P, D and F, and why this number of electrons like 2, 6 and 10 and 14. So if you look at the whiteboard, you can see that this is the arrangements of the orbital according to the number of shells, like n equals 1 to 2, 3, 4, 5, 6, 7 and 8. And you must know these oblique lines will give you the pathway of how you will go through these orbitals. And if you just think that number of elements, what are the product numbers of elements, based on that if you go through and then you stop when your product number will stop. So according to this way, you please continue your electron configurations. I am just explaining in a very primary level regarding the arrangements of electrons in energy levels. In next video, I shall go through a very elaborately how the electrons are arranging into different elements and atoms. So take care, and of course do let me know what is your requirements, and please do let me know that you understand my lecture, and if you like it, please give me in comments that how it feels like when I talk and then how I explain. So see you on the next class. Take care, stay well, stay blessed. Bye.